Morning, everybody. Welcome to week 2 of Geometry at Home. So we are going to get started with section 6.2, which covers kites and trapezoids. Okay, so we're going to start off with everybody's favorite summertime activity, and that is a kite. Okay, believe it or not, that is actually the name of a geometric shape. So two things that stand out about a kite is it has two pairs of congruent sides, and those congruent sides are also consecutive, which means they are next to each other. Remember, that's an old word there, consecutive. So let's squeeze all that down a little bit. There we go. That looks a little better. Oh my goodness. Okay, so congruent sides, these ones right here are next to each other. These ones right here are also next to each other. Another thing that is an important point is the same thing with angles. This angle is right next to this angle. Those are congruent. This angle is next to this angle. Those two are congruent. Not these though, okay? These are not congruent to each other. So the ones that go along, the angles that are right in between the two sides that are equal, those ones are always going to be congruent, okay? So make sure you have that picture. Now this, we're going to do a couple of questions. It says, what is the measure of angle AXB? Well, that kind of leads us to our next thing. If you take a look, angle AXB, let's follow AXB. If you follow those letters, what you can see is that looks really close to being one of these special types of angles. It has a box, which we know is named a right angle. So that means that angle is how many degrees? I didn't hear everybody, but maybe that's just because it's Sunday afternoon for me and you're watching this a different time. But it's 90 degrees. That's what it is. 90 degrees is the answer. Okay? So in a kite, the angles that are in the middle are always 90 degrees. So that's part A. What is the measure of AXB? It is 90 degrees. Okay, bear with me because I'm typing. I can't really write with a computer. Okay, next. If AX is equal to 3.8, what is AC? So let's go back to the picture. AX, let's look at the letters. AX here. If that's 3.8, then AC, that goes all the way across here. Well, oops. Well, here's another key point to this whole thing, is if we have this thing is called a diagonal, the segment. If we have two diagonals in a kite, they are bisecting each other, which means they cut each other in half. So this little segment is equal to this little segment. So if we said this is 3.8 and we want to figure out the whole thing, AC, then that means we need to do 3.8 times 2, and that's going to come out to equal 7.6. Okay, so there's our answer for A. Here's our answer for B. Now we need to talk about part C. It says, if BD equals 10, does BX equal 5? So here's BD all the way across. If that's 10, would we say that BX right here is 5? Does this look like, we know that 5 is half of 10. Does this segment look like half of all this? The answer to that one's definitely going to be a no. No, it does not bisect. Okay, so we can say that BD is not bisected. So there's our answer for C. All right, it's a little tricky stuff. So make sure if you're able to get onto the computer, there's an interactive book that's kind of nice that kind of goes along with these, and talks about them maybe a little different way, which maybe it will be more helpful. So definitely check that out. I would do that if I were you. But moving along with our lesson here, example 2, we're talking about a kite again. It says that it wants to know, part A, what is the measure of angle 1? Well, here's angle 1 right here, and it looks like it's kind of in that little corner. And whenever we have a corner, that would be our 90 degrees. So 90 degrees, that's our first answer. All right, right there. 90 degrees is going to be inside of the little corner here. Now, part B wants to know, oh, there we go. Part B wants to know, what is the measure of angle 2? Well, for angle 2, it's in this little corner here. I'm going to outline something for us. We have a shape right here. We have a triangle, and we know that a triangle is how many degrees? That would be 90 degrees. I'm sorry, 180 degrees. Sorry, I was thinking about this part. So, if we know all of these angles in here are right angles, that means if we have a triangle that adds up to 180, we're going to take 90 plus 35, the two angles that we know, and that comes out to 125 degrees. And then we'll take 180 and subtract 125, and that's going to leave us with 55 degrees. So the measure of angle 2 is equal to 55 degrees. So there's a couple of triangles that are formed inside of here. And if we know that they add up to 180, and you know two of those measures, that's how we do. Add them together, subtract that number from 180, and then we're good to go. Okay, and then now we have this last one, angle 3. And what's going to happen here is when we take a look at, there's a triangle formed on top here. Well, like we said on the last page, these angles are always equal. So if we came out to saying that this angle here, angle 2, is 55, then that means that this angle here is going to be 55. So that's 55, that's 55. If that's 35, this angle here has got to be 35 degrees. So that is our answer for those. I'll go ahead and I'll box up all of our answers here so we see them. I'll say this measure of angle 3 equals 35 degrees. Okay. All right, so we're going to move along here. We'll do another example. Now, the first one it asks is, what is the measure of angle 1? So just like how we saw right in the middle of a kite, there's always a right angle, right? The dollar store is going to have some kites coming out pretty soon. It's going to be summertime. I would recommend going and get a kite, take a look, see, they got a right angle right in the middle. Anyways, I know everyone's going to do that. So let's go ahead and let's think of this as another right triangle, okay? And the first question that they ask is, what is the measure of angle 1? Okay, right here. So, measure of angle 1, once again, we have a triangle. So we're going to take 90 plus 32, okay, because we have 90 degrees, we have 32 degrees, that equals 122 degrees. And then to find the missing angle, 180 minus 122, that comes out to equal 58 degrees. And that's going to be our answer for part A. Okay, so we'll put 58 is the measure of angle 1. How about angle 2? What do you think? Look at angle 2. That's sitting over here. Well, kind of looks a lot like the last example too, doesn't it? The last one, we saw two angles right next to each other that were both 55 degrees. So this angle 2, it's right next to that 32 degrees. You can bet your bottom dollar that that is also going to be 32 because, and I'll draw a little visual here, this angle is equal to this angle. Man, that is tough to do with a mouse. Okay, a couple more things to move on with. A couple theorems that you'll see. You'll have a chance to look at them when these notes are saved. But in an isosceles trapezoid, okay, well that's what this thing is right here. Okay, it's a trapezoid. There's two sides that are parallel, but the two sides that are not parallel, they are congruent. That makes it an isosceles trapezoid. Okay, in isosceles trapezoid, each pair of base angles is congruent. That's talking about A and D, but it also means B and C. Okay, so you're going to come across a few things like that, where if it's a trapezoid like this, it's a picture that looks like this, and you'll see more examples of it. The angles down here are going to be equal, the angles over here are equal. Okay, and then same thing to be said about the diagonals. If we have diagonals, BD, this diagonal, is going to be equal to AC, that diagonal. All right, that is always true when we are talking about an isosceles trapezoid. So an example here. It says, given that we have an isosceles trapezoid, PQRS, what are the measure of all of these angles? Let's see how good my mouse writing is here. So the first one, if we know that's 135, then this one's got to be the same. That's going to be 135. My goodness, that looks terrible. Hopefully you can see that. Okay, now the ones that are next to each other, here's a trick. The angles that are right next to each other this direction, that are clearly not the same measure, they're going to add up to 180. So we need to do 180 minus 135, and that's going to leave us with 45, which means this is 45 and this is 45. So there's our answers. They wanted all three of the missing angles. We gave it to them. Okay, next part, it asks if we assume that ST and RU are parallel. That's what that symbol means, and the only reason they tell us that is to make sure that we know that it is a trapezoid. What is the measure of angle TUR? TUR, that's right inside of here. Okay, the information that they give us is this is 47 degrees. So that's on the outside. So we need to figure out what the measure of the angle on the inside is. This kind of goes back to the stuff that we worked on before. If they're a straight line, they add up to 180. So 180 minus 47 comes out to 133, which means that right there is 133. And guess what this angle is? 133. Heck yeah. So the final answer to that one is 133 degrees. Okay. Almost getting done here. Almost done. A couple things. This problem looks so complicated. It looks so complicated. But if we look at this, here's the info that they give us. If measure of angle 1 is 138, what is the measure of angle 2? Well, if this is 138, then this is 138, and then to find angle 2, 180 minus 138 gives us 42. So 42 degrees. Okay, that one's not so bad, but this next one's going to take us a little bit of time. Okay, this next one, they pretty much took this bottom part and moved it down here. So we don't need that one anymore. But it says the cross support is 4C plus 3, that's this. And the other one is 6C minus 5. What is the length of each support? Okay, so like we said earlier, these diagonals are always going to be equal because we know that this is an isosceles trapezoid. I'm going to go back to typing. So since they're equal, we're going to say 4C plus 3 is equal to 6C minus 5. All right, we're going to set them equal. Now, what is the first step that we're going to do? We have to get all the variables on the same side. So minus 4C from both sides, minus 4C from both sides. That leaves us with a 3 equals 6C minus 4C is 2C minus 5. Okay, what's our next step? Got to add 5 to both sides. Okay, which is going to leave us with 8 equals 2C. Move this over here. All right, one last thing that we have to do. We we have to divide both sides by 2, which is going to leave us with c equals 4. Now, does the question ask us what c equals? No, it says what is the length. So what we need to do is plug it in. Now, lucky for us, we know that they're both equal, so we only have to do it once. So let's plug it in here. It's 4 times c. So instead of putting c, we're going to put a 4 here because that's what c equals. C equals 4. That's plus 3. Okay, so 4 times c plus 3. 4 times 4 plus 3 comes out to equal 11. Where's my equal sign? There it is. And that is our final answer here. Okay, a little bit complicated, but that's stuff we're going to need to do. Okay. We are starting to run out of time that I can record this, so I'm going to move on to this last section here. And this is the mid-segment theorem, okay? When you have a line that goes in the middle of a trapezoid, that is called a mid-segment. So that's this guy right here, that XY is a mid-segment. And what's true of it is if you do AD, this side here, plus BC, this side here, and then divide that by 2, that is going to be the length of this. It's the number that's right in the middle of the 2. Okay, so this example problem is kind of tricky. It says this JM right down here is 4/5 of XY. Come on, really? You gotta make the problem like that. 4/5 times XY. Well, lucky for us, we know what XY is. It's 25. That looks terrible. I'm gonna fix that. I'm sorry. But that we know is 25. So what we're gonna start off with is we're gonna do 4/5 times 25, not 28. And that comes out to equal 20, okay? So you could do that in your calculator. You could do 4 divided by 5, get like 0.8, and multiply it by 25. That'll give you 20. So we know down here is 20. Okay? And what we need to do is figure out what this side is, KL. So we're going to put an X. So let's follow kind of this format. The mid-segment, 25, equals, parentheses, the two sides that we know, X plus 20 divided by 2. Okay, I'm going to move this over. X plus 20 divided by 2. I'm going to make this look a little bit better because we're going to have to solve this. Divided by, not X, 2. Okay. So, first step. First thing that we should do, strongly recommend to you, let's get rid of this 2 down here. Let's multiply both sides by 2. That means these go see ya. 2 times 25, that leaves us with 50. And then on the other side is just X plus 20. We subtract both sides by 20. X comes out to equal 30. Very good. Very good. Okay, that's the end of our notes. Okay, just a couple things that are here. On this next slide, you see that we just have a couple different things with kites. Okay, these angles across from each other, equal. These little angles next to each other, equal. These are also equal. These little pieces of a segment are equal, and these are 90 degrees. Okay, and I'm kind of speeding through this, but I don't want to run out of time on my computer. This page, bunch of trapezoids, all kinds of different. This is what a basic trapezoid looks like. Isosceles, we know those two parts are equal. And those angles. And then one thing we didn't really get a chance to touch on, yes, these are equal to each other. And isosceles, these are equal. But it's also true that the top half of each diagonal are equal to each other, and the bottom halves are also. So that's kind of nice. That's an added little bonus. Okay, so that we have reached the end of our 6.2 lesson. Please, any questions you have, feel free to send me something on Remind, send me something on Google Classroom, whatever the case is, send me an email. Hopefully everyone's doing well, and we will catch you guys on the flip side. All right, take care of yourselves.